Hey, today, Algebra 2, 5.5, Apex version. So today, we're going to talk about finding polynomials with factors. So we've been working on using division and factoring and all of our methods that we know, factor by grouping, to find our factors and our solutions. But now we say we are given these, and these are not factors, these are roots. Okay. So we're going to find a polynomial with these roots now. Okay. So remember that this means x equals -3, x equals 1/2, and x equals 1. Okay, but we need to work backwards. So when we were working through these problems, we were always finding factors first. In other words, x plus 3, okay, in parentheses equals 0. Okay. And now we're going to work back, and then we would go to our roots. Now we're going to work backwards. So we need to get each of these set equal to 0. Okay, so to get this set equal to 0, I'm going to add 3 to both sides, and I get x plus 3. So that is my first factor. Okay, roots, factors. Okay, here I'm going to say x equals 1/2. So I need to subtract 1/2 from both sides. Okay, and I can get x minus 1/2. Okay, I don't like working with fractions, so I'm going to multiply the whole thing by 2, and I get 2x minus 1. Okay, that's the same exact thing, means the same thing. Okay, you could also do it from here by multiplying everything by 2 first and then subtracting 1. Okay, either one works. And here I'm going to subtract 1 from both sides, and I get x minus 1. Okay, so now I'm working to find the polynomial. So in the past, I was dividing to find these factors. What's the opposite of dividing? Multiplying. So now I'm going to multiply to find these factors. I'm sorry, to find the polynomial. Okay, so now I'm going to start by multiplying. It doesn't matter which ones I multiply, but I need to choose 2 of them to multiply first. So I'm going to go ahead and just multiply these 2. So x plus 3 times 2x minus 1. And I'm just going to FOIL. So first outer inner last, so x times 2x squared, x times -1, -1x, inner 3 times 2x is 6x, 3 times -1 is -3. Okay. So now I'm going to combine my like terms. Okay, but I'm not done yet, okay, because I still haven't used this x minus 1. So now I'm going to multiply this entire polynomial by x minus 1. So here I'm going to get 2x to the third. So I'm just going to multiply everything by x first, plus 5x squared minus 3x. And then I'm going to multiply everything by -1, minus 2x squared minus 5x plus 3. And lastly, combine my like terms. So I get 2x to the third squared. So I have a 5x squared and a -2x squared, so plus 3x squared. And then I have a -5x and a -3x, and then I have a 3. Okay, so I had 3 roots. My polynomial has a leading degree or exponent of 3. Okay, so I know that I at least have the correct type of polynomial here because that's a 3 and I had 3 roots. Okay, if you want to check it more, plug it into your calculator. Okay, plug it into your calculator, see if it crosses at these 3 spots. If it does, you are on the right track. Okay, let's go ahead and take a look at the next one. So we're going to do the same thing. So we have 3 roots. So we should have a polynomial that has an x to the third in it when we finish. Okay, so x equals 2, x equals 2/3, and x equals 4. Okay, so I'm going to get these all set equal to 0. So x minus 2. Here, I'm going to do this one by multiplying by 3 first. Remember I said you could do that. So those cancel. And I'm left with 3x equals 2. And then I subtract 2 from both sides. Okay, so once again, it works either way. Okay, and you could leave it in factor form or fraction form too. It doesn't matter. I just prefer not to be multiplying stuff by fractions and then adding fractions together, okay, which I assume most of you don't want to add fractions together either. So this is going to be x minus 4 when I subtract 4 from both sides. Okay, so now I'm gonna multiply two of them together. This time I'm just gonna go on ahead and multiply those two together just because I feel like it. Doesn't matter. Okay, remember which order you multiply them in. Okay, so now I'm gonna FOIL, so I get x squared minus 4x minus 2x plus 8, which is x squared minus 6x plus 8. Okay, but I need to multiply that by my third factor, 3x minus 2. I was saying 3 and writing 2. Okay. So now I'm going to go on ahead and multiply 3x times all of these. So I get 3x to the third minus 18x squared plus 24x. Now I'm going to multiply negative 2 times everything minus 2x squared plus 12x plus 8, so minus 16. Now I'm going to combine my like terms, so I get 3x to the third. Okay, and that's right, I should have a polynomial to the third power. Okay, minus 18, 19, 20, so minus 20x squared, combining my like terms. 24x and 12x is plus 36x minus 16. Okay, and if I graph this in my calculator, I should get these zeros. Okay. All right, so we're going to take a look at another one. So the next one says write a polynomial with the following roots: 2i, 3, and 0. Okay. So let's go on ahead and start working this the same way. So we're going to set x equal to 2i, okay, x equal to 3, and x equal to 0. Okay. So one thing that we have to remember is that if there's an imaginary, it also has the complex conjugate. Right? So let's go on ahead. You can do it two ways. You can either get this set equal to 0 and then write the factor that's the complex conjugate, or you can say, well, if x equals positive 2i, then I know that x has to equal negative 2i. Okay, so two different ways to do that. Okay, so now let's go ahead and get all of these set equal to 0. Okay, this one's already equal to 0, so we don't have to do anything with that. That is a factor already. Okay, so x minus 2i, x plus 2i, x minus 3, and x. So those are my factors. Now, when you are working with imaginaries and radicals, you are always going to want to multiply the imaginaries or the radicals first because it's going to get rid of those terms. Okay, so we're going to FOIL this. So it's x squared plus 2ix minus 2ix minus 2i squared. Minus 4i squared. Okay, so these cancel, these go away. So remember, we're getting rid of the imaginary because have you ever seen a polynomial with an imaginary in it? No. Okay, that's because when we do this, it goes away. Okay, so now we have x squared minus 4 times I squared, but what is I squared really? It's a negative 1, so we have x squared plus 4. Okay, so now that is where we're at so far, okay? X squared plus 4. But now we still have two more terms that we have to multiply by. So let's go on ahead and multiply by x minus 3 first. So we get x to the third plus 4x. So I multiplied both terms by x. Now I'm going to multiply both terms by negative 3. So negative 3x squared minus 12. It does not look like there's any like terms to combine. We can go on ahead and rearrange this though, so it's in standard form. So remember, that means we start with our leading degree, okay? And then we work our way down. So then it would be minus 3x squared plus 4x minus 12. Okay? Now you notice here's a 3 and we had 4 roots. So we haven't done something yet. Oh, look, we haven't multiplied by x yet. So the whole thing needs to be multiplied by x, and we get x to the fourth minus 3x to the third plus 4x squared minus 12x. Okay. All right, so we're done with that problem. Okay. We're going to look at another problem here. So this is a grain silo. So it's a word problem. So it says a grain silo is in the shape of a cylinder with a hemisphere top. The cylinder is 20 feet tall and the volume of the silo is 2,106 pi cubic feet. We want to find the radius. So the first thing I'm going to do here is I'm going to draw a little picture of my grain silo. Okay, so it looks like that, and then it's got, you know, a top on it. Okay. So we know that the height of the grain silo of the cylinder is 20 feet tall because it tells us. We know that our total volume is 2106 pi. Okay. So now we need to find the volumes of each shape and add them together. So the volume of a sphere is 4/3 pi r cubed, but we're only using half of the sphere. And the volume of a cylinder is pi r squared times the height. Okay. So let's go on ahead and let's simplify this. So this is really 2/1, which means we're multiplying by 1/2. Okay, and I'm just showing you how I'm getting what I'm getting. So I'm getting 4/6 pi r cubed. Okay, so let's go on ahead and write this out. So we know our total volume equals these two volumes added together. So 4/6 pi r cubed plus pi r squared height. The very first thing I notice here is that there is a pi in every single one of these. So if I divide every single term by pi, it gets rid of those pi's. Okay, which we can't have a pi as part of our radius anyways. Okay, so now I'm at 2106 equals 4/6 pi, oh, not pi. I got rid of the pi's, remember? R cubed plus r squared times height. Okay, well, I'm looking for radius. Okay, so just pretend it's an x, right? X cubed, x squared. Okay, so now I need to get it set equal to 0. Okay, so now I'm left with a polynomial and I can solve it. Okay, I can solve it by factoring. I can solve it by division. I can solve it by whatever method I need to solve it by. And if I plug it into my calculator, yeah, hold on, my graph from my previous one is graphing now because I accidentally hit graph. Okay, so all right, so I'm going to say parenthesis 4 divided by 6 x to the third plus x squared. Uh-oh, I have an h in there, but really I know that my h is 20. Okay. Minus 2106, and I'm going to go ahead and graph this. And just from looking at the graph, I can see that I have a 0 or a root at 9. Okay. So then I know that my r is going to equal 9. Okay, and then I could go on ahead and do the synthetic division just to solve it and to show me the work if I said so, show the work. Okay, but the big thing here was getting this polynomial set up. Okay. All righty, and let's move on to the next part of 5.5. Let me find it here on my paper. So the next thing is just more how you can find, narrow down what your solution should be if you don't have a calculator. Okay, because a lot of times on tests, on AP tests and such, they won't let you use calculators to do some of this. And so this just is all going to help. So we have Descartes' rule of signs. So it says the number of positive real zeros. In other words, your answer is x equals a positive real number. So 2, 2.4, 3.87, okay, positive numbers is either equal to the number of variations of signs or less than that by an even integer. Okay, so we're going to look at this before we talk about the negative real zeros. Okay, so this says positive real zeros. Okay, so for positive reals, We're going to look at the number of sign changes. So this changes from a positive to a negative, so that's 1. This changes from a not positive to a negative, so that's 2. And this changes from a positive to a negative, so that's 3. So we know we have to have 3 roots, okay? So this says that we can have 3 positive roots, okay? Or 3 take away 2, okay? And the reason we take away an even number is because we could have negative roots, okay? Or 1 real positive root. Okay, so that's what that tells us. So we look at the total number of sign changes, okay, that's the maximum. And then we would take away 2 if we still have values that we could take away and not hit 0 yet or get to 0, then we would keep taking them away. Okay, so if we had 4 sign changes, then we would say 4 or 2 or 0. Okay. All right, so now let's look at the number of negative real zeros. So the number of negative real zeros, in other words, it's x equals a negative real number, is either equal to the number of variations of signs of f of negative x. So notice this one was just the original function. This one we're going to have to plug negative x in everywhere we see an x, or less by an even integer. Okay, so the first thing we have to do here is we have to plug negative x in. Okay, and then we're going to have to solve it. Okay. So negative x to the third. So negative x times negative x is positive x, times negative x is negative x. So that's going to be a negative 3x. And that's why we have to do the math here before we do anything. Negative x squared is negative x times negative x, which is positive x, times negative 5 makes it negative 5x. Okay, this one we don't have to do anything but separate it out. So negative 6x and then negative 4. So now we're looking for the number of sign changes. So no sign changes, no sign changes, none. Okay, so 0, 0, and 0. Okay, they were all negative. Okay, so that what that means is that there are 0 negative real roots. Okay. So that means that there has to be 3 positive roots in this case. So if we did our P over Q like we had been doing, okay, we would get plus or minus. It would be, so that's factors of 4, so 1, 2, and 4, all over factors of 3. Okay, but now we know that we can take out all of those negative options. Okay, so once again, it just helps us to narrow it down. This is going to help us narrow it down even more. So this is upper bound or lower bound rules, and we're going to look at these separate again. Okay, so it says upper and lower bound. So if you have a polynomial with real coefficients, in other words, the coefficients are real numbers, and a positive leading coefficient, that's important. So the very first number, okay, has to be positive. Okay. We're going to divide by some root using synthetic division. Okay. So let's go on ahead and let's start with this one, and let's divide by x equals 1. Okay. So I'm going to divide by synthetic division, and I have my 6, my negative 4, my 3, and my negative 2. And I didn't skip any, so I didn't have to use any placeholders, any zeros. 1 times 6 is 6, that's 2. 1 times 2 is 2, that's 5. 1 times 5 is 5, and that's going to be 3. Okay. So now here it says, if C is greater than 0, which it was, okay, and each number in the solution is either positive or 0, then C is an upper bound for real zeros. Okay. In other words, okay, these were all positive numbers or 0. Okay, so that means there are no roots to the right of x equals 1. Okay, so when we were, if we did our P over Q, okay, we would get, let's see, what would we get? We would get, negative 2, so that would be plus or minus 1 or 2 over 6, which would be plus or minus 1, 2, 3, and 6. Okay. So we know now that it cannot be anything above positive 1. So on this graph, okay, here's x equals 1. Our roots are all going to be to this side, positive 1. Okay, but now let's look at the lower bound. So the lower bound says essentially the same thing. So if we're dividing by a negative number, then and each number in the solution are alternating positive and negative, where C can be either, or sorry, 0 can be either, okay, then it is a lower bound. Okay, so let's do the same thing. So now let's take this same one, but we're going to divide by negative 1. So 6, negative 4, 3, and negative 2. Okay, and once again, this is just helping us narrow down our roots so that we can solve it by hand, because a lot of times you might have to be able to do that. Negative 1 times 6 is negative 6. That's negative 10. Negative 1 times negative 10 is positive 10. That's 13. And negative 1 times 13 is negative 13. That's negative 15. So once again, we don't care about remainders or anything else. All we care about is at this point, if it's a lower bound or an upper bound. Okay? So this was a plus, a minus, a plus, and a minus. So that means x equals negative 1 is a lower bound. Okay. What that means is that there are no roots to the left of x equals negative 1. Okay. So negative 1. So all of our roots are going to be between those two numbers. Okay. This also gave us some additional information. We know that because we did not get 0 on any of these are not zeros. Okay? So we know that our solution is not going to be negative 1. Our solution is not going to be positive 1. And it's not going to be 2 over 1. So it has to be 1/2, negative 1/2, 1/3, negative 1/3, or 1/6, or negative 1/6. Okay, so we've just narrowed down what we're looking for and where the zeros are going to be. You will use this sum. Okay, you need to know this. As you get into calculus, you will use it a lot more. Okay. All right, have a great day, and I will see you all next time.